Hey there, Mr. Weaver here, and this is Topic 8, Lesson 4, Features of Quadratic Functions. After this lesson, you need to be able to identify features of quadratic functions, specifically from a graph. You'll know you're successful after this lesson if you can determine the direction of the parabola based on the leading coefficient, if you can identify the vertex, maximum or minimum, axis of symmetry, y-intercept, and zeros from a parabola, and if you can determine the domain and range. In the next few lessons, we are going to be dealing with quadratic functions. So a quadratic function, if you remember back to when we were naming polynomials in topic 7, it is a function with an exponent of 2. So the highest degree is just 2. And x to the second power is the most basic quadratic you can have. It's a quadratic monomial. A parabola is just the graph of a quadratic function. So this picture here and the one on the next slide, or a little bit farther down on your note page, is also a parabola. It is sort of a U-shaped graph, and there are some special characteristics about it. Each parabola has what is called a vertex. It is the coordinate of the highest or lowest point of the parabola. So on this parabola, you can see that dot there is where our vertex would be. That coordinate would be at -3, -6. The vertex is going to be very important as it helps us to figure out other things as well. Each parabola will also have a maximum or a minimum. So the maximum is the highest y value that the parabola reaches. The minimum is the lowest y value that the parabola reaches. So the parabola on this slide has a minimum. It has a low point. So the lowest y value is y equals -6. Notice it's the same y value in the vertex. On the next slide and in the other parabola on your page, it has a maximum or highest point that the parabola reaches. One characteristic that's shown kind of in a hidden way in the graph is called the leading coefficient. That is the value that is going to be in front of x squared in your function. And that's actually going to tell you what direction the parabola opens. If the leading coefficient is positive, the parabola is going to open upward. If the leading coefficient is negative, the parabola will open downward. And that leading coefficient can also help us figure out if we're going to have a maximum or a minimum, although it might be the opposite of what you think. The leading coefficient can also tell us how wide or narrow our parabola is. When we're thinking about this, think about the absolute value of the number, which means you're just taking the value, whether it was positive or negative, and making it positive. If that value is between 0 and 1, your graph is going to be wider than just x squared. So if it was -3/4, 3/4 is between 0 and 1, it would be wider. If it was positive 1/2, it's going to be wider. If the absolute value is over 1, so -2 or +4, then your graph is more narrow than it would be if it was just x squared. You're going to get a skinnier parabola. Our next feature is the axis of symmetry. It is an imaginary vertical line that passes through the vertex and divides the parabola in half. And some people also call it a mirror line. This axis of symmetry is going to have an x equals a value. So here it's x equals -3. If you would have figured out the vertex of this one, which is -3, 6, you would notice that the axis of symmetry has the same x value as the vertex. The axis of symmetry can also help us because every point on the parabola has a point that is the same distance away but on the opposite side. So there we have two arrows. The points that they go to are the same distance away from that axis of symmetry on opposite sides. That can be very useful when you're trying to find a value, but you know what the other one is on the other side. The y-intercept is the y value when x equals 0, or the place where the parabola crosses the y-axis. It's the same meaning as we saw with other function types earlier in the year. In linear functions, exponential functions, and now quadratic functions, it is the place where the graph crosses the y-axis. Many times in context, with quadratic functions, it's going to be your initial height, which we will get to later in lesson 6. So here our y-intercept is 0, -3, or just -3. Our next feature on our graphs are called zeros. So zeros are the point where the parabola crosses the x-axis, essentially when y equals 0. They're also called our x-intercepts or roots or solutions. So those two dots there are where it crosses the x-axis. This graph has 2 zeros. Now, depending on the parabola, you can have either 0, 1, or 2 solutions, or zeros. It all depends on how many times that graph crosses the x-axis. And we will look at more about figuring out how many solutions it has in the next unit. Finally, let's review 2 words we learned earlier in the year. They mean the same thing here, domain and range. So domain is our x values for the function, or your input. Without context, your domain for your parabolas is going to be all real numbers. It's always going to be able to open wider and wider and wider, going left to right. Your range, on the other hand, is your y values, or your output. This is the one that you're going to have to figure out. Now, the range all depends on the vertex and the maximum or minimum. If the parabola has a minimum, the range will be y is greater than or equal to that minimum. The y values are going to be above the minimum. That's where the graph is located. All the points on the graph are above that minimum. If the parabola has a maximum, then it's the opposite. The range will be y is less than or equal to that maximum, because every point has to be below that maximum. We'll look at some examples of how you can tell where the range is coming up shortly. Now, let's look at a few examples using these features of quadratics. So first here, identify the direction of the parabola. We are given the equation y equals -2x squared minus x minus 2. If I want to know the direction, that's asking, is it opening up or down? Well, we are going to look at the leading coefficient, which is the number in front of x squared. So here, the leading coefficient is -2. Negative means that it is opening down. So the parabola would be opening downward. I also added on here a short bonus question. So will it be wider or narrower than x squared? For this, we need to think about the value of that leading coefficient. So if I were to take the absolute value of it, I get 2. 2 is more than 1, so it's going to be more narrow than x to the second power. Remember, larger numbers are skinnier or more narrow. Now it's your turn. Pause the video, identify the direction of the parabola, then see if you can figure out, will it be wider or narrower than x squared? Let's check. You should have found that the graph is opening up because the leading coefficient is positive. So the graph of the parabola would open up and look something like that. Will it be wider or narrower than x squared? This one will also be narrower. The leading coefficient is greater than 1. It will be more narrow than x to the second power. Now let's look at an example where we are identifying some features from the graph. So here we want to identify the vertex, if it has a maximum or minimum, and then the domain and range. Let's start with the vertex. The vertex is the coordinate of the highest or lowest point on the graph. So here we have a high point. What is the coordinate of that point? It is at -2, 4. So the vertex is just the coordinate of the high or low point. Now we want to figure out, does it have a maximum or minimum, and what is it? Well, based on this graph, it has a high point. It has a maximum. So the graph goes up, reaches that maximum at the vertex, and then starts going back down. Where is the highest point? It is at 4. So we would have a maximum at y equals 4. Again, notice it's the same value as the y coordinate of the vertex. For domain, it's going to be all real numbers. Again, it keeps getting wider and wider as it goes down, meaning we could keep having x values that we could test out. Our range, on the other hand, since we have a maximum, the graph is everywhere below that. So the high point was at 4, and then the graph is everything below that. So my range would be y is less than or equal to 4. 4 was my maximum. It's also the y coordinate of the vertex. Notice you're using the same numbers each time. Now it's your turn. Pause the video. From this parabola, identify the vertex, maximum or minimum, domain, and range. Let's check. You should have found these values. The vertex is at 3, -4. This graph has a minimum at y equals -4. It's the lowest point that it reaches. The domain, still all real numbers. And this time the range was above the minimum, so y was greater than or equal to -4. Let's look at one last example. Here, let's identify the axis of symmetry and y-intercept and determine if the leading coefficient is positive or negative. So starting with the axis of symmetry, remember, it goes through the vertex. It is our imaginary line that cuts the parabola in half. What is the equation of that line? It is going to be x equals 1. If you had figured out the coordinate for the vertex, which is at 1, 0, then we would take that x value, x equals 1. The y-intercept is where it crosses the y-axis. So that point right there. What point is that at? It is at 0, 1, or again, we could just say 1. So it crossed the y-axis 1 unit up. Finally, is the leading coefficient positive or negative? Well, to determine this, I'm going to look at the direction of the graph. It is opening upward, which means that the leading coefficient is going to be positive. Now it's your turn. Pause the video. Based on this parabola, identify the axis of symmetry, y-intercept, and determine if the leading coefficient is positive or negative. Let's check. You should have found the axis of symmetry is x equals -3. That imaginary line right there. The y-intercept is 0, 3, or just 3. That point right there. And this parabola is opening down, so our leading coefficient would be negative. In this lesson, we learned about quadratic functions and the different features that the graphs have. So a quadratic function is just a function with the highest degree term is x to the second power, and its graph is called a parabola. We saw many features of quadratic functions, and each can help tell us something about the function, especially in context, which we will learn more about in lesson 6. We saw the vertex is either the highest or lowest point on a parabola, and that coordinate can help us identify the maximum or minimum and the axis of symmetry, which divides the parabola in half. The y-intercept, as we saw in previous units, is where it crosses the y-axis, which was similar to linear and exponential functions, while the leading coefficient that we saw tells if the parabola will open up or down. Finally, we had zeros, which is where the parabola crosses the x-axis, and those points can be very useful in context, especially thinking about flying objects and where they would hit the ground. We also revisited domain and range that we learned about in previous units. Domain tells the possible x values, while range tells the possible y values. Out of context, our domain is going to be all real numbers, while the range will be either greater than the minimum or less than a maximum. And looking at the graph can help you figure out what it is. So after this lesson, do you know how to determine the direction based on the leading coefficient? Can you identify the vertex, maximum or minimum, axis of symmetry, y-intercept, and zeros on a parabola? And can you determine the domain and range for our parabola? If you're not sure about these things, go back and look at the different examples to really solidify your understanding of where each thing is located. You will need to know where things are located in future lessons. And that's the end of lesson 4 on features of quadratic functions.